Alright, we are now looking at 8D. And 8D has to do with identifying horizontal asymptotes and vertical asymptotes of a rational function when you don't have a graph. So we're solely going to be looking at the equation. Okay. So horizontal asymptotes, again, are horizontal lines the graph does not pass. And horizontal asymptotes, when we're finding them from an equation, have to do with the degree of the polynomial. And the degree of your polynomial is your highest exponent. So whatever the number of your highest exponent is going to be the degree of your polynomial. So looking at example 1, we want to find the degree of each polynomial. So I have 5, 3, 2, and technically this is 0. So that's a good thing to pay attention to. So the degree of this polynomial is 5. Same thing here. We have 2, 3. Again, technically this is x to the 0. 4, and this is x to the 1. 2, 3, 0, 4, 1. The highest one is 4. Okay. So, when we're looking at functions, we have 3 rules. Okay, rule 1. If the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, it comes into what we call a slant asymptote. We don't look at slant asymptotes in this class, but you will learn about them in pre-calc. Okay, so if their degree of the numerator is higher, we just say there's no horizontal asymptote. If they are equal, right, then y equals the coefficient, and we really say the lead coefficient of the numerator, that should be an m, divided by the leading coefficients of the denominator. Okay, so really when they're equal, you're going to get a number, whatever that number may be. When the degree of the numerator is less than the degree of the denominator, you get y equals 0. Okay. So these are our 3 rules. We'll have to kind of like memorize those 3 rules. All right, looking at number letter A. So we want to find our degrees first. Again, this doesn't have an x, so it's x to the 0. This one has a degree of 2 is my highest number. Okay, so 0 is less than 2, so my numerator is less than my denominator. Right? So then I look at my rules. If my numerator is less than my denominator, then we get y equals 0 as my horizontal asymptote. Okay. Looking at B. Okay, my degree, right, is 1. And my degree here, same thing, is 1. So my numerator equals my denominator. All right, these 1 and 1 are equal. So therefore, y equals the leading coefficient divided by the leading coefficient, right? Coefficient is the number in front. So this one has a 1 in front. This one has a 1 in front. So y equals 1. All right. 2 more examples on this part. Okay. X cubed minus x squared minus 6x, and over negative 3x squared minus 3x minus plus 18. Right? In my numerator, the degree is 3. Right? That's my highest. Degree is 2. Okay? So the numerator is greater than the denominator. So therefore, no horizontal asymptote, right? That's the rule there. Last one. We're missing something there. That's all right. It doesn't matter what it is. Here, our degree is 2. Here, our degree is 2. Right? So our numerator equals our denominator. So then our rule is, right, y equals, right, our leading coefficient over our leading coefficients. So our horizontal asymptote is going to be at y equals negative 1/4. Okay? All right, looking at the next page, we are going to look at our vertical asymptotes as, vertical asymptotes in holes as well in this video. So our points of discontinuity, right, points of discontinuity are vertical asymptotes in jumps, or vertical asymptotes in holes, also called jumps. A vertical asymptote occurs there is a factor in the denominator. Okay? And this comes from we can't divide by 0, right? We've talked about that rule before. So if there's something in the denominator where I can set it equal to 0, then it's going to have a vertical asymptote. A hole comes from a factor canceled out of the numerator and denominator. Okay. So if I simplified my rational function and something canceled out of both the numerator and the denominator, then that value gives us a hole. Okay, because it kind of just disappeared. Okay. So if we look at our steps, right, we want to completely factor the numerator and denominator. So again, factoring is another big thing in this one. Any factors that are common, you set equal to 0 and solve for x, and that's your whole. Any remaining factors, you set equal to 0, and that's your vertical asymptote. Okay. So let's look at number 1. 4 over x squared minus 3x. Okay, I can't factor my numerator. In my denominator, they both have an x in them. That's the greatest common factor. So, for holes, I don't have any holes because I don't have anything I canceled out. Vertical asymptote, I have a factor here, so x equals 0. And then we have a factor here, so x equals 3. Right? Again, we're switching that sign. We've seen that before. If you need the work, right, it's x minus 3 equals 0. We add 3, so x equals 3. Right? That's really what we're doing to get this. I'm not going to do it on every problem. Okay, so we should start again. start being confident in those things and just seeing them right away and not having to do the work for them. Looking at B, we can factor this. Okay, we can factor the numerator, right? It is quadratic and it has two terms, no GCF. So we're taking the square root. Over 3x squared minus 6x minus 9 has a greatest common factor. Okay. This is still a quadratic that I can factor. Right. -3, -2, so that's 3 and 1, right? So -3 and +1. Wholes. All right, what do I have in common? Well, I have an x minus 3 and an x minus 3 that cancel. So that means I have a whole at x equals 3. Vertical asymptotes. This 3 doesn't matter. Again, I'll show why. If I say 3 equals 0, if there is nothing I can do to make this true, okay, so while there is a 3 in the denominator, it doesn't tell us anything about a vertical asymptote. So it's really just from this x plus 1. So x equals -1 is our vertical asymptote there. Okay. All right, C, x plus 2 over 2x plus 6. X plus 2 I can't factor. 2x plus 6 has a greatest common factor. Nothing cancels. So if we're looking for a whole, there is none. Right? I don't know what is happening here. Vertical asymptote. That's not what I wanted to do. Asymptote. There we go. Got it. Again, there's this 2, which is a factor, which doesn't do anything, right? There's no way to solve for x. And then x plus 3, so x equals -3. There's a lot of 3's in these problems. All right, and last problem. F of x equals 2x squared plus 10x plus 12 over x squared plus 3x plus 2. I'm going to start by factoring this one. So I have 2x squared plus 5x plus 6, right? So I just took out that greatest common factor over x squared plus 3x plus 2. I'm going to factor this one. That's 2 and 3. Factor this one, multiply to 2, add to 3, that's 2 and 1. Okay, weird order, that's okay. So, starting with our whole, does anything cancel? Yes, I have an x plus 2 and an x plus 2 that cancel out. So that means I have a whole at x equals -2. Vertical asymptote, do I have anything left in my denominator? Yes, I have an x plus 1, so that means x equals -1. One thing I want to point out, which I didn't in this one, but I could have also done here, right? If there's something left in your denominator, that doesn't matter for your wholes or vertical asymptotes. Okay, we just can't divide by 0. Okay, I can divide 0 by something else, so it doesn't matter that this is 0. It only matters if your denominator is 0. So only things in your denominator matter for your points of discontinuity. Okay? All right, and that is it. I'll see you guys tomorrow.